Hey, what's going on, guys? Steven here, and today we're doing another Leetcode video. This time, we're going to be solving Leetcode 1095, Find a Mountain Ray. Let's set up a timer for 20 minutes. 20-minute timer, and hopefully I'll be able to explain the problem to you guys. So, let's just read the problem first. I first like reading the function name and description to see if we can get an idea of what we're doing. We're finding something in an array, it looks like, with the API of get with the index and length, which you can just call on the self. So I'm guessing that just gives you the length of the array. Okay, let's see what we're supposed to do here. You may recall that an array is a mountain array if and only if the array's length is greater than or equal to 3. There exists some I with 0 less than I, so I in between, such that R of 0 less than R of 1 up to R of I. And then, so, mountain, it's increasing up to index I. And then, so, increasing up to index I, decreasing up to from I to the end of the array. Cool. Given a mountain array, mountain R, return the minimum index such that mountain R dot get index equals target if such an index does not exist, return -1. You cannot access the mountain array directly. You may only access the array using the interface. And then submissions making more than 100 calls will get wrong answer. Okay, cool. So let me see the constraints. 10 to the 4th, 1,000, 10,000. And where can our peak be? Can our peak be... Okay, so the only edge case I'm worried about here is finding basically if the peak is like not in between two values. But I think what we're supposed to do is find a peak, right? And we can do that through binary search, which will log of 10 to the 4th is definitely less than 100. So if we get to 5 and our target is 3, then we can binary search on the array from 1 to 5, and we can binary search on the array from 5 to 1 in order to find this target. First, we should find from the left to I to get the minimum index. Otherwise, it's going to be on the right, or it's not going to be in there at all. And that way we can also have a sorted order for each of our 3 binary searches. So first binary search will be like finding a peak in any array, and then which you can know by just like moving your pointer to where the direction is going. Okay. Okay. Okay.
Are you talking to someone? Where is the SUV key?
Sorry, guys. We're back. First binary search will be like finding a peak in any array. Then binary search from the left, from index 0 to the peak, which is just regular binary search. Otherwise, binary search from peak to index, which is binary search just in a decreasing sorted list. Cool, I think that'll be our algorithm. So let's implement it. First, we want to know the length of the mountain array, so let's do length n equals mountain r dot, what did our API give us? Dot length. And then we don't even care about the target, right? We want our two sorted list. So say L equals 0, R equals n minus 1, while L is less than or equal to R. If, sorry, let's calculate our midpoint. M equals L plus R minus L divided by 2. If nums of M is greater than nums of M minus 1. Let's first do some index checks. If M minus 1 is greater than or equal to 0, and M plus 1 is less than length is less than N, and nums of M is greater than nums of M minus 1, and nums of M is less than, or sorry, is greater than nums of M plus 1, then we have found our peak. So peak equals 0, peak equals M. Cool.
George kept saying that you don't speak English well.
If
That is why.
L if, sorry guys,
George was explaining why he was calling.
L if nums, if M minus 1 is greater than or equal to 0,
When Daddy's at work, you call and then
and
put Daddy on the phone.
nums of M
Give him consent. A verbal consent.
is
Or is there a form Daddy can sign?
greater than
Email it to georgemarysway@yahoo.com.
nums of M minus 1, then we want to keep searching in the upwards direction, so we're going to go L plus equals 1, else R minus equals 1. Or R or M equals, or L equals M plus 1. Sorry guys, I don't know why I was messing that up. L equals M plus 1, and then R equals M minus 1. Because in this case, it'd be nums of M is less than nums of M minus 1. So if it's less than the one before it, then we would want to search in the left direction. Cool. So, and we want to break after we find our peak. Cool. So we have found our peak. Now, let's do def binary search L to R. L equals or while L is less than or equal to R, if, and let's include target as well, if, and then M equals L plus R, L plus R minus L divided by 2 to count for overflow. That will give us our midpoint, and we will say if nums of M is equal to target, then return M. I'm gonna have to rename all this. Am I? Mountain r dot get M -1. Oh boy, guys.
Heavy snow, Steven. I think you just need to stay there. Probably until Tuesday, okay?
Sorry guys about that. Okay, we only got 5 minutes left. So, if nums of, or, shoot. I think we gotta do if mountain array. Return M, elif is less than target, I was gonna put it all inside a regular binary search function, but I think because we're doing different binary searches on decreasing versus increasing, we gotta just do it hard coded for now, at least with the time limit pressure. And I gotta fix all this. Cool. Cool. Okay, I think we got that part right now. And then elif mountain array dot get M is less than target. If it is less than the target, then we want to move our left pointer up. So L equals 0, R equals peak. Else R equals M minus 1. Yep, that's right. And then I think we can just copy this all. Then we can do L equals peak, R equals N minus 1. And then from here, it's a decreasing array, so I guess if mountain array is greater than target, then we want to move our left pointer up. Yep, because target would definitely be on the decreasing side. else our if it is less than, then it's going to be on the side more towards the peak. So yeah, that's right. And then we will just return -1 if we haven't returned anything yet. Cool. Awesome. Unfortunately, something happened here. Our peak is 5. Our target is 2. But our output is -1. Why is that? 5. Use test case print peak. So our peak is at index 4. 0, 1, 2, 3, 4. That found our peak, right? Oh. Ah. So here our peak is at index 0. Still saying peak is, it's not calculating our peak correctly. I am going to debug this with you guys. Let me see how long this video is. Okay, it's 17 minutes. Trying to see what I did wrong. If I just do this. That'll not change anything. Oh, I see. So it doesn't hit this. There's a ray of length 5. So okay, it'll hit 3. It won't hit this. This is not greater than, so it'll come here. And then 3 is greater than, it won't hit that. So it'll do r equals m minus 1. So r is here, L is here. And then it'll land on 0. I see. Yeah, I don't know what's happening. I'm supposed to land on 5, right? But it lands on 3. Goes r equals m minus 1. Goes peak is 0 now. Because 0 plus 1 divided by 2 is 0. And then it'll land on 3 at the index 0. It'll hit. It should hit this. But it doesn't. I see now. Maybe if I just do an or clause and hard code for it, it'll work. So yeah, if I do a or clause, yeah, I think this should work. Or I see I made too many calls now. Okay, guys. I think that works if I don't make too many calls. I'm trying to think what to do. I could just say awesome, awesome. It looks like I made too many calls again. See a way we could get rid of calls. Oh wait, I'm dumb. Just do this. Okay, bet. We got it, guys. Sorry if that took way too long. Just store it inside a variable. Amazing, guys. Wow, we did it. Alright, guys. That's clearly a log of n. We do 3 binary searches, so 3 log of n, but overall time complexity log n. Thank you, guys. Bye bye.